Welcome to the Teja Statistics. Today we are learning the previous year's examination question paper, semester 4, that is inference. Just see the questions, that is define null hypothesis and alternative hypothesis, explain the most powerful test, write the general test procedure of large sample test, define order statistics, explain its correction for continuity, write the assumptions of t-test, define run and length of a run, define non-parametrical tests and write its any two advantages over parametrical tests. Next, coming to the part B, state and prove Neyman-Pearson lemma, explain importance in testing the hypothesis, obtain the most powerful critical region for testing H0 mu equals to mu naught versus H1 mu equals to mu 1 for normal distribution mu comma sigma square and the population. Next, explain the large sample procedure for testing the equality of two population standard deviations. In a random sample of 500, the mean is found to be 20. In another independent sample of 400, the mean is found to be 15. Could the samples have been drawn from the same population with the standard deviation 4? So, which test you have to apply here? Here you have to apply the large sample test for two means. Next, explain the Fisher-Jet transformation, explain its all applications, describe the large sample test procedure for equality of two proportions, describe the chi-square test for testing the goodness of fit, derive the chi-square test for 2 by 2 contingency table. Very important question. This is 10 or 11A, the second one. Explain the small sample test procedure for testing the equality of population variances. Explain t-test of significance of single mean. Very important and previous year's question paper, this one. Next, in continuation, explain Wald-Wolfich run test for testing the equality of two populations distribution functions, determine the percent shrinkage of a synthetic fiber. Tests were made at two different temperatures. 10 tests were at a lower temperature and higher temperature. The resulting data are given below. Shrinkage, that are 1 to 10, and lower temperature and higher temperature values are they given. Use an appropriate non-parametrical test to type whether the present shrinkage of a synthetic fiber were made at two different temperature or equal or not. Simple and easy calculations. And which test you have to apply here? This is a non-parametrical test. So equal values are they given. So pair of values you have to observe and you can calculate by using the given data. Next, explain the parametrical test versus non-parametrical test. Explain Mann-Whitney U-test procedure. Very important and easiest questions. Next, in continuation,